There is a common misunderstanding that data analytics requires you to be able to code in Python. But Python is just a tool. The objective of data analytics is to be able to extract insights from data, and it does not really matter what tool you use to achieve it. Yes, Python is very powerful, and if you can learn how to use it, that's great. But as I will hopefully demonstrate through this video, there are better tools that you can use. The second thing I would like to point out is that most of the times data analytics involves reusing known ideas or solutions rather than coming up with something revolutionary or groundbreaking every time you are trying to solve a problem. So if you are used to coding in Python, think of the collective time that is wasted across teams and departments and across organizations trying to code the exact same data analytics logic again and again. So we definitely need a better way of sharing and reusing data analytics ideas and solutions. But can you really innovate if you are using someone else's ideas or solutions? The answer is yes, you can. Because a lot of the times, innovation comes from deep understanding of the state-of-the-art solution in one area and being able to apply it in another. For example, you can try using data analytics solutions for challenges in the aerospace industry to maybe solve problems in the financial markets. And this is where the KNIME Analytics platform outshines any competition today. It is 100% open source, so you can use it for free, and you don't have to code. Instead, with KNIME, what you do is you use a mouse to drag and drop reusable chunks of data analytics logic onto a whiteboard or canvas on your screen and literally glue them together to solve your problem. It is almost like playing a game of Lego. And the key benefit of this approach is that you can focus on the problem and optimizing your solution rather than on writing and fixing errors in your code. KNIME also allows you to share your data analytics solution with your friends and colleagues and the open source community. Well, that's enough talking. Let me show you what I mean. You can install KNIME on Windows, Mac, and Linux. This is what the user interface looks like on a Windows PC. In KNIME, the reusable chunks of data analytics logic is referred to as a node. And you can find the full list of nodes under the Node Repository section of the user interface. The nodes are grouped by themes so that it is easy to find what you're looking for. For example, nodes that allow you to read and write data files are grouped under the I/O or input-output category. In total, there are over 4,000 nodes that are currently available in KNIME. It is worth mentioning that when you first install KNIME, you will have to install the KNIME extensions first before you can access the full list of nodes. Let's expand the I/O node category and briefly explore what's underneath it. Let me select this Excel Reader node. As you can see on my screen, the description section now contains additional information on what you can do with this Excel Reader node. The canvas is your playground where you will build your end-to-end data analytics logic. Let me drag and drop the Excel Reader node onto the canvas. What's next? Well, I have to specify which file on my computer I want the Excel Reader node to open. Right-click on the node and you will see a number of options to choose from. The Configure option allows you to customize your node so that it does exactly what you want the node to do. Let me open this Configure window. As you can see, there are a whole bunch of options that you can use to specify how exactly you want the Excel Reader node to behave. If you are not sure what one of these node settings mean, always refer to the node documentation under the description section I showed you earlier. The other thing to note is that different nodes will have different configurable settings. Let me add another Excel node to my workflow. Now let's say I want to join the two datasets represented by these two Excel reader nodes. Let me search for a node that offers a join functionality. As you can see from the explanation, this joiner node seems to be what I'm looking for. So let me add this node to my workflow. You'll notice that each node has one or more of these arrowhead type symbols. They represent the data feeds going in and coming out of the node. If you are not sure what the inputs and outputs of a node are, use the node documentation for guidance. In this instance, I want the output feed of the Excel reader node to be the input feed for the joiner node. So let me join them using my mouse. It is worth noting that the Excel reader node does not have an input feed, as it is reading a data file directly from my computer rather than receiving a data feed from an upstream node. I hope you can see how easy it is to use KNIME. Now, if you are wondering what a complete end-to-end data analytics workflow in KNIME looks like, I have an example for you. This is a credit scoring model based on an anonymized open source historical dataset. As you can see on my screen, you can include annotations and narratives to explain the workflow. So let's say you have created a workflow like this. The next obvious question is, how do you execute it? There are two different ways of doing it. You can either manually execute the data analytics logic in each node like this. Alternatively, you can execute the entire workflow at one go like this. One of the good things about KNIME is that you can inspect the outputs of each node so that you can confirm it is doing what you expect it to do. Let me scroll the screen a bit so you can see what I am doing. In the remainder of this video, I will share some tips on how you can start using KNIME. We will begin by browsing through the node repository to get an understanding of what kind of nodes are currently available in KNIME. Under the Input-Output category, you'll find a bunch of KNIME nodes that allow you to read from and write to different types of files, such as CSV, Excel, images, PDF, and HTML. There are also nodes that allow you to connect to services on the cloud, such as Azure, AWS, and Google Cloud Storage. And then there are various file utility type nodes that allow you to zip or unzip files and create or delete files and folders. The data manipulation nodes allow you to filter, split, combine, and transform tabular datasets. The view nodes allow you to create data visualizations such as bar chart, histograms, scatter plots, and pie charts. The analytics category has nodes that offer machine learning techniques and traditional statistical methods for analyzing data. The DB nodes allow you to connect to various databases and perform database operations such as execute read and write queries. With the scripting nodes, you can add Python and R codes to a KNIME data analytics workflow. This is useful when you come across situations where you need a custom logic that is not possible to implement using the existing KNIME nodes. KNIME labs contain nodes that are being actively developed, such as nodes that integrate with the TensorFlow deep learning library. In the interest of time, I'm not going to go through the remainder of the categories, but when you do find some time, do browse to the list of nodes to get a sense of what you can do with KNIME and how powerful this platform is. My final tip for beginners is to browse through the examples that you can access directly from KNIME. It will give you a feel for how you can use the various KNIME data analytics nodes. I hope this was useful. And yeah, give KNIME a try. It is completely free, so you have nothing to lose.